Okay, linear quadratic systems. I just want to go through a few examples and then I'll turn you loose on that assignment. So, linear quadratic systems are just that. They're just systems of equations where one or more of the equations are linear and one or more of the equations are quadratic. So how could we solve this system? And you already know. Click them all the way close. Say it again. Move the x over. I mean, maybe you're moving in the right direction, but you could. But there's something, we don't even really have to do that. There's something that's going to work in any system. What do you think? Okay, true. That's graphically that works. But if we're going to solve this algebraically, this means we're not relying on technology. We've got to use algebra. So what do you think? You have an idea?
Substitution.
Substitution, sure, right? Just like we did with lines, I mean, this is an ideal one right here. This is just served up to us to substitute because it's already solved for y, isn't it? Right? So there's our substitution equation right here.
Are you recording?
I am recording, yep. And so then we can just substitute right there for y. Right? And then if I substitute for y, I'm eliminating y, and I'm just only ending up with x's, right? Whichever variable, the variable for which we substitute is the variable that goes away, right? So what do we get if we do that? So here's our 3x minus 2 times y, and y is all that stuff. 1/4 times the quantity x minus 3 squared equals 13. So now what? Say it again. I'm going to solve for x, right? So I'm going to simplify first, maybe. If I distribute the 2, well, I don't really distribute, I just multiply. 2 times 1/4. I'm going to get 3x minus, what is that, 1/2 times x minus 3 squared equals 13. What's probably a smart thing to do here right now before I go any further? What's ugly about that equation? There's one little ugly thing there you don't like. The fraction. How do we get rid of the fraction? Okay, let's just multiply both sides of the equation by 2. Yeah, if we multiply both sides by 2, we'll clear the fractions. Okay, what's that give us? If I distribute my 2, I'm going to get 6x. The 2 is going to cancel the 1/2, right? So 6x minus the quantity x minus 3 squared equals 26. And now that's just a quadratic equation that we can deal with. Right? I'd have to expand out the x minus 3 squared. And a mistake that I sometimes see you guys doing, so I want to just point this out, is how you distribute this negative, right? What's the order of operations here if we're simplifying? You know, we have to follow PEMDAS, so we have to do the exponent first and then multiply, meaning distribute, right? So what is the x minus 3 squared? If I square that out, what do I get? Okay, and we're subtracting that whole thing, right? So you got to put that in parentheses, and that's a common mistake I see is that people don't put that in parentheses, and so only the first term ends up being negative, and that's not correct. I have to distribute it through the whole thing. So if I do distribute, I'm going to get 6x minus x squared plus 6x. Well, 6x plus 6x is what? 12x. Okay, so let's just combine all this stuff. And then minus 9 equals 26. What if we push everything over to the other side to make it positive, right? We want a positive number of x squares, don't we? We always want a to be positive in a quadratic equation. Actually, you know what? I'm not going to do that. I want to reinforce that step. So let's just subtract the 26. So we get negative x squared plus 12x was that minus 35? And then here's an important step. We've got this minus there. We don't want that. So we're going to multiply each side by -1. Change all the signs. There. So now we've got our, that's good. Now we've got our quadratic equation in standard form, right? So that means we've got it in the form ax squared plus bx plus c equals 0, where a is greater than 0, right? And now we would go back to unit 2 and solve that, right? So how are we going to solve that one? What's going to be the best strategy? Magic numbers, yeah, right? We can't isolate x because we have x squared terms and x terms, but magic numbers exist. What would they be? -7 and -5. Good. So we end up with x minus 7 times x minus 5 equals 0. So either x equals 7 or x equals 5, right? Okay, no big deal. So that one, most of that was just kind of review of solving quadratic equations. But the main thing here was this is one where we were able to substitute. Substitution is probably the most common form of solving, the strategy we have for solving systems. What about something like this guy? I mean, we can substitute, but to substitute there, I'd have to isolate a variable. That's not hard to do. We could isolate a y in the bottom one, couldn't we? Right? What else could we do, though? I mean, we could. Isolate the one on top would be fine, too. But is there another, so we could substitute easily. Is there another strategy? I mean, we had 2 of them for linear equations. Elimination would work too, right? We could also just add the results of the left side and the right side of the equation. And if we do that, what's going to happen? If I just add these equations vertically, what happens on the left side if I add those up? Yeah, look, the y's are going to cancel. I get 3x minus y plus 4. So the y's would cancel, and I get 3x plus 4. On the other side, I just get 7 plus the expression on the right on the bottom equation, right? So 2 times the quantity x plus 5 squared plus 7. And then I just solve the quadratic equation, right? Make sense? Okay. What about, so I'm not going to go any further. That one's not a big deal. Okay, what about this one? This is one I kind of want to do. At least I want to get started on this, because I want to show you a good trick. You see a lot of that. So what do you think? Which solution, or which method do you think you're probably going to choose here? Probably elimination, right? What are we going to do to that bottom equation? And we want to multiply by 3 anyway, don't we? You want to clear that fraction. Everybody see that? So we're going to end up getting then, and let's maybe rearrange these. Let's maybe rearrange these a little bit. So we'll switch sides. So this goes to the right side and that goes to the left side, just so they match up better, right? So we get our top equation. So what about the bottom one? If I multiply through both sides, I multiply both sides through by 3. Those cancel, right? And so I'm going to get a 23 on one side. And on the other side, I'm just going to get 3. Is that a negative? Is that a negative on the bottom? I think it is, isn't it? So on the other side, I get a negative 3x plus 3y. If I flip those around. And so now I could just combine those through elimination, couldn't I? Right? Does that make sense? Okay. And if I do that, so the y's cancel, and I just get negative 3x plus 9. Agreed? Okay. Now what if? What if we wanted to use substitution? Which is fine. Maybe there's a situation where it would have been easier for us to use substitution after multiplying through by 3 on the bottom. What could be my substitution variable? So if I'm going to use substitution instead, okay, what variable could I solve for? Could solve for y. Could solve for x. Now, which equation would I solving for x, I would say may not be quite as good an idea. How come? Got to deal with the squared, because I have an x inside a quantity that's being squared, right? So maybe I want to solve for y. But there's a better substitution than solving for y. There's an easier one. What is it? If I could solve for y, but if I go through the hassle of solving for y, think what the steps are going to be if I want to solve for y here. I'm going to have to add 3x to this side. I'm going to have to divide the whole thing by 3. And then when I plug it back in up here, what am I going to end up doing anyway? Wow, what about 3y? Everybody see that? Why not? Why solve for y? Is there something magical about having a y as one of my... No, it doesn't make any difference. Why am I substituting? I'm substituting because I want to combine the equations into one equation with one unknown, with one variable, right? So why not pick the easiest possible substitution, which would be 3y. Look what I've got here. I've got a 3y there and a 3y there. Solve for a 3y, right? So in this bottom equation, in fact, we could even solve if we wanted to for negative 3y, right? If I want to solve for negative 3y, I could just subtract that term to the other side and subtract the 23 to this side and get negative 3y equals negative 3x minus 23. And then there's my negative 3y I can plug into the top equation, right? See that? It's not like that's some huge, profound trick, but you see it a lot. You see it a lot like in calculus, too, when you're making variable substitutions. Pick the easiest one. If you happen to have, a 3y and a 3y, and you want to get rid of y's, we'll just make that substitution instead. Okay, let's see. One last one. Why did I pick this one? Can't remember if there's a reason for this or not, but let's just try this one, see what happens. Okay, so what are we probably going to do here? You take your pick, but I could use elimination. I could just add these two sides up, right? I could combine these two together and these two together. You see that? And so then on one side of the equation, I'm going to get x minus 1 squared plus 3. On the other side, I'm going to get negative y plus x plus y, so my y's cancel. So I just get an x, right? And now I've got a pretty easy equation. X minus 1 squared plus 3 equals x. Okay, so let's solve this. I hope there's a reason I picked this one. There must have been. So if I square this out, what do I get? X squared okay. So we'll put it in standard form. Right. I'll subtract the x to this side. I get x squared minus 3x plus 4 equals 0. Now what? Maybe. It is actually going to be imaginary numbers. But let's find them. Maybe that's why I did it. There's 3 directions though, actually. We're only looking for real solutions, right? But there are none, so what do we put? False. Okay, but let's remind ourselves, how do we know that there are none? That's why I did this one. Yeah. What do you think?
Because if you subtracted 3x from x squared, you have a number less than 0. So negative and subtracted squared, you have negative.
No, we can't say. I mean, if we can't say that because we'd have to go through the whole process of completing the square, right? But there's a way we can easily tell. What's our method for always? If I have a quadratic equation in standard form, which this is, right? So if we start here, what method do we always have for finding solutions to a quadratic equation in standard form? We can always fall back on. Say it again. Quadratic formula, right? So we always know if this is true, then negative b plus or minus square root sure. Okay, so we get the quadratic formula. Well, where's the only place that the i's are going to come from? Right, right. If the, what do we call this thing? It's the center of the radical. What do we call that?
Conjugate.
No.
What does it start with?
What is it? Discriminant. So if the discriminant is positive, we're getting what?
Reals.
2 reals, right? I get 1 for the plus and 1 for the minus. If the discriminant is exactly equal to 0, I get 1 because the plus and the minus give me the same result. And if it's negative, of course, then I'm getting i's, and so I get imaginary solutions, right? And so in this case, all we'd have to do is check the value of the discriminant. Negative 3 squared minus 4 times 1 times 4 is less than 0. So we get imaginary solutions, right? Make sense? Okay, so it's false. All right, good work.